Good day to you. Welcome to another session of our class. In our last class, we studied trigonometry and we discussed Pythagoras theorem, and we saw how it was applied and why Pythagoras theorem was applied to that particular question. Now, what if the question has two unknown sides? What if the triangle has two unknown sides? Remember, we said for a right angle triangle, which is a triangle that has an angle at 90 degrees, if the two sides is known, A and B, and we are to look for one side, automatically we apply Pythagoras theorem. But what if we have two unknowns, x and y, and only side B is known? We cannot apply Pythagoras theorem, and since it's a right angle triangle, we cannot apply sine rule or cosine rule. Automatically we apply the trig ratio, which is the Sohcahtoa. Now, what is the Sohcahtoa? Sohcahtoa is an acronym which is divided into three. Sohcahtoa. So we have the first ones, we have it as Sohcahtoa. So this first so is SOH, which symbolizes S stands for sine whatever the angle is, theta, is equal to O stands for opposite, divided by the next one, H stands for hypotenuse. Now, last class I showed you what opposite hypotenuse is or are in a triangle. Now, the next one is our CAH, which stands for cos. C stands for cos theta or cos whatever the angle is. A stands for adjacent, and H, as usual, hypotenuse. Then the last one is our TOA, T-O-A, where T stands for what? Tan. Yes, T stands for tan theta. O stands for what? Opposite. And A stands for what? Adjacent. This is just the formula to solving trigonometry using the Sohcahtoa, the sine, cos, and tan. Now, the sine divided by the cos, we also always give you the tan. We can prove that, or prove that later. When you divide the sine by the cos, you have the tan. So, if we are to solve a question now, for instance, and we're asked to look for, we're told here is maybe here is 3 meters, and this our angle here is 30 degrees. We are asked to look for x and y. We cannot apply Pythagoras theorem. Why? Because we have two unknown sides. The only way we can apply Pythagoras theorem is if we have only one unknown side. So if you have a equation where there are two unknown sides, don't think about Pythagoras theorem. Think of the next rule to solving a right angle triangle, which is the Sohcahtoa. I told you to solving a right angle triangle, we apply these two. While to solving other types of triangle, isosceles triangle, equilateral triangle, and the rest other type of triangle, we apply sine rule and cosine rule. So since we cannot apply Pythagoras theorem to this question, what we apply is the sine rule, is the Sohcahtoa. Sorry, what we apply is Sohcahtoa. So how do we know which of them to apply? Are we applying sine, cos, or tan? That's the next question. How do we know which to apply? Now, the question will tell you which to apply. If we are to solve first for x, automatically if we draw a line from this 30, our x becomes what? Our opposite. Why our y is what is side opposite the 90 degrees, which is our hypotenuse. So now 3 meters is our what? Adjacent. So that means our x is our opposite. So we have opposite is equal to x. Hypotenuse is equal to what? Y. And adjacent is equal to what? 3 meters. So now, if we consider sine theta, opposite, which is what we're looking for, by hypotenuse, that is x over y, we will not be able to get an answer because x is unknown, y is unknown. So we have to pick opposite, which is unknown, and one known, adjacent, or hypotenuse and adjacent. So which of the formula contains opposite and adjacent in it? Opposite and adjacent, that's tan. You see it? Tan contains opposite and adjacent. Why are we choosing opposite and adjacent? Because opposite is unknown, adjacent is known. So we cannot solve using two unknown. We have to pick one unknown and pick one known so that we'll be able to solve it. So we apply tan theta. So if we apply tan theta, our theta becomes what? 30 degrees is equal to what? Opposite over adjacent. What's our opposite? X. What's our adjacent? 3. So tan 30 is equal to x over 3. Now what is tan 30? So if we consider our special angles, tan 30 is root 3 over 3 or 1 over root 3. So we have tan 30 as root 3 over 3 is equal to what? X over 3. Now what is special angles? We will have a class on special angles. where you'll be able to get the angle of a particular trig using solved form or in solved form. So I'm going to have a video on where we'll treat special angles. So you'll be able to produce something like tan 30, sin 60, cos 30, cos 60, tan 45, and the rest of them in solved form without a calculator. I think that's what they use for JAMB and other exams we're doing here in Nigeria, and most exams abroad too. They don't use calculator, they just use special angles. So I'm going to make a video on special angles. So just sit back, relax, and watch out for the link. Yes. So this is a denominator. This is a denominator. We know in the rule of mathematics, denominator can cancel out the denominator. Numerator can cancel out the numerator. You know, denominator is the one below. We call it denominator. While the one above, we call it numerator. So since we have a denominator and a denominator having the same value, automatically we can cancel them out. So it means that this numerator x is equal to this numerator root 3. So that will be our answer. Simple and short. Now if we had applied Pythagoras theorem, for instance, we would have gotten an answer. We wouldn't have even gotten close to an answer. So you see how to apply how to solve right angle triangles using Pythagoras theorem and the trig ratio. You use Pythagoras theorem when you have one unknown, while you use the trig ratio when you have two unknowns. And when you are solving for a particular angle in a right angle triangle, Pythagoras theorem should never come to your mind. What should come to your mind is trig ratio, except you are solving for a side, then you use Pythagoras theorem, and that is just one side where the other two sides are known. But for angles in a right angle triangle, use the Sohcahtoa. Just use the Sohcahtoa to always give you the right answer. So that is how to get that. Now, for instance, let's take another example. So we have a triangle. Don't mind my angle that is 90 degrees, that it is smaller than other angles. Now, one thing you should know is when you are giving a diagram in any exam or in any question or whatever, don't look at the diagram, look at the description of the diagram. That is how you are able to get the correct answer. Now, if you look at the diagram, automatically you should know this can never be 90 degrees. Yes, but I have told you, the examiner has told you, the person in charge has told you that this is 90 degrees. So take it as 90 degrees. What it means is that the side opposite this 90 degrees is your hypotenuse. That is the main thing you need to know. So this is our hypotenuse. Now, the question continues. We are asked to find theta and alpha. Now, the first thing is, what are we going to apply? This is a right angle triangle. Automatically, we apply Pythagoras theorem and the Sohcahtoa. Now, which we apply first? We have two sides and we have one side unknown. So automatically, Pythagoras theorem must go. So we apply Pythagoras theorem, which means here is if this is our 90 degrees, and we are to consider this angle theta, then where will be our opposite? The side opposite the angle theta, which is this one. So for theta, for angle theta, which is unknown, our opposite is equal to 3 meters. Our adjacent is this other side, is equal to 4 meters. Now, whenever the angle changes, the opposite and adjacent side changes. What does not change is the hypotenuse, because hypotenuse is always opposite the 90 degrees. So wherever the angle, if we are to consider angle alpha, then our opposite will be what? 4 meters. So you see it's going to change. Our adjacent will now be what? 3 meters. But since we are considering angle theta, automatically our opposite is that, adjacent is that. So now, to apply our Sohcahtoa, what we'll do is hypotenuse square is equal to what? Opposite square plus adjacent square. Hypotenuse square, hypotenuse is what? S square. Opposite is what? Wherever side you like, 3 meters. And adjacent is what? Wherever side you like, 4 meters. So we have it as S square is equal to what? 9 plus what? What's 4 square? 16. So S square is equal to what? 25. And X is equal to what? The square root of 25. So when you have X square is equal to that, then you take the square root of both sides. So square root of S square will give you X. Square root of 25 will give us that. So square root of 25 is what? 5 meters. So we have this as what? 5 meters. That is the first thing. Now we have all sides. Now we are looking for this angle theta and angle alpha. So if we are to solve for angle theta using opposite as this and adjacent as this, which trig ratio are we going to apply? Where we have opposite and adjacent. opposite, no adjacent, adjacent, no opposite, opposite and adjacent, we have tan. It's not always going to be tan. Yeah, but what you do is which of them is given, which of the formulas do we have the given items. If we have the given items in cos, then apply your cos. If you have it in sine, apply your sine. So we apply tan because we have opposite and adjacent which is given. So we use tan theta is equal to opposite over adjacent. This is where I got the formula from. From the beginning of the class, you should understand how we're able to get this tan theta. So we have tan theta is equal, those are opposite 3, those are adjacent 4. So we have a value of tan theta equal to 3 over 4. Now what is 3 over 4? 0.75. I have it as 0.75. So our tan will become the tan inverse or the arctan of our answer, 0.75, which will be what? What will be the answer? Tell me in the comment section below. So that is that. Now if we are to solve for alpha, as our alpha being unknown, now what will be our opposite? It's not going to be 3 any longer. Remember, your opposite always change with the direction of the angle. So the opposite is always the side opposite the angle. So automatically opposite becomes what? 4 meters. Thank you. Opposite is equal to 4 meters. Now the other side is what? 3, which are adjacent. Adjacent is equal to 3 meters. You see, as the angle change, the opposite and adjacent change, but the hypotenuse remain the same. Now the same thing also, if we want to solve this, we can, since we know our hypotenuse as 5 meters, we can decide not to apply tan opposite over adjacent. No, we can decide to apply sine since we have opposite and we have hypotenuse, or cos since we have adjacent and hypotenuse. We can apply any of them. So let's apply sine instead, because we have this and this. We have this as unknown, so let's apply sine. So it will become sine alpha, no longer theta. Theta is just the name of the angle. Now we're looking for alpha, which is on that name of another angle, is equal to what? Opposite over hypotenuse. So opposite over hypotenuse. Now we have it as sine alpha is equal, those are opposite, 4. What's the hypotenuse? 5. So what is 4 over 5? 0.8. So if we take the arc sine of both sides, what I mean is arc sine of sine alpha is equal to the arc sine of 0.8. Now in mathematics, physics, chemistry, any calculation, whatever you do to the left hand side, you also replicate it in the right hand side. That's how you know that that what you did is mathematically correct. Now this other side of the equality sign is called left hand side, while this other side is called right hand side. Like standing here, right and left. So whatever you do to the left hand side, if I added sine inverse with left hand side, automatically I must add sine inverse with right hand side. So this sine inverse, we cancel sine, we are left with what? Alpha is equal to, what is the sine inverse of 0.8? Tell me in the comment section below also. So you see how we're able to get this theta equal to arctan. This is just the long method of doing it. What I would have just done is tan theta equal to this, theta equal to arctan of this, sine theta equal to this, and alpha is equal to this, alpha is equal to arcsine of that. So that is how you solve using Sohcahtoa. Now we are going to have a video on examples of trigonometry, as I've told you also when I taught you Pythagoras theorem. Watch out for the video, check the description, watch out for the description. When you see it, you watch it, you practice. If you have any question, you can tell us in the comment section and we'll make a video concerning that. So you can apply this to either elementary mathematics or advanced mathematics, whatever type of mathematics. As far as you are dealing with a triangle, automatically these 4 rules must obey. These 4 rules must apply depending on the type of triangle. So if we are to apply trig ratio to a triangle that is not a right angle triangle, which means a triangle that does not have one of the angle at 90 degrees, then we'll consider sine rule and cosine rule. That will be in our next class. So watch out for the video. Thank you for watching our video. Make sure you subscribe, so when we post a video, you'll be among the first sets of people to get the notification. Subscribe, click the subscribe button below, click the bell, and thank you very much.